Alright, today we'll be talking about geometric transformations with matrices and just working with them. Okay, so today we'll be talking about the pre-image and the image. Okay, the pre-image is actually the first image. It's the image before you start doing anything, and this is just an image of an actual triangle in the coordinate plane. Now what you want to do is you want to be able to actually represent this as a matrix. So what you're going to do is when you represent it as a matrix, you're going to actually have a row for x's and a row for y's. So I'd strongly recommend have the x's on the top and the y's on the bottom. Okay, so it'd be 2, comma 4, or sorry, not comma, 7, and then on the bottom 3, negative 1, 2. Okay, let's move that a little bit so everyone can see. Okay, and so this is what we're going to be dealing with right here. Now normally what I would do is with the translation, okay, what I would do is I would just go ahead and write it in the form of x plus a number, let's say I want to move it to the right 3, and then y minus 2. Okay, and then I would just write out what my image was over here and just work with it that way. But sometimes if you're dealing with a large picture, that's not going to be feasible, so you have to make a matrix out of it. So what I'm going to do is we are going to take our matrix, we're going to make it the same size, okay, and on the tops are going to be the 3's, and then the negative 2's on the bottom. Okay, let's move that over a little bit. There we go. Alright, and so obviously I'm going to add these together to get my actual image and what it's going to be. Okay, now if it's really killing you to do the image, I think you can do it on your own and stuff, but I'm just giving you the idea of what a geometric transformation is actually going to look like. So the image is going to be the final dealing with. Okay, translations are really easy to work with. Now, if we were doing a dilation, and the dilation has to be centered at the origin, okay, so it's centered there, you're just going to multiply by a scalar. Now, if you're enlarging, the scalar is going to be greater than 1, and if you're shrinking, it's going to be greater than 0, but less than 1, okay? Right, so you're just going to have to be careful when working with that dilation, but the dilation is very simple to work with. Alright, now we're going to talk about rotations about the origin, and when we talk about rotations, we're talking about counterclockwise. Okay. Alright, so a 90-degree rotation about the origin, you're going to multiply by this matrix. Okay. And obviously you're just going to have to deal with 2 points at a time. 0, negative 1, 1, 0. Okay, if you want to do a 180-degree rotation, it would be negative 1, 0, 0, negative 1. Something pretty simple. 270 degrees would be 0, comma 1, negative 1, comma, or negative 1, 0. Okay, and a 360-degree rotation, I bet everyone can guess that it's just the identity matrix. Okay. All right, now talking about reflections for coordinate planes. Okay, if we were reflecting across the x-axis, it would be 1, 0, 0, negative 1 is what we would need to multiply by. Okay, if it was across the y-axis, and obviously this is just for 2 by 2, and this is coordinate plane stuff. Negative 1, comma 0, 0, comma 1. Okay, if it was across the y equals x line, it would be 0, 1, 1, 0. Okay, and then across the y equals x, or the y equals negative x line, 0, negative 1, negative 1, 0. Okay. Alright, so reflections and rotations, you're actually going to be doing some matrix multiplication, okay? Alright, but if you take your time and you just pay attention to rules as you come across them, it's going to make your job a whole lot easier. Now, this stuff is actually used in Photoshop, so you use this quite a bit when either you are translating or whether you're moving an object, or whether you're zooming in or zooming out, or whether you're doing the rotation, or if you're just doing a simple reflection. You know, you use this stuff every day when you use Photoshop. But this is actually the simple math behind it. Obviously, they're going to have a lot more complex math, but this is just the ideas behind the coordinates of the actual pixels, okay? All right, that is it for working with transformations in geometry for Algebra 2B matrices, okay? I will talk to you later. Bye.